We had such a lovely time in the hallway. Woohoo.
Okay.
All right, so we're going to keep going with this because we've got some solving to get to today. So we're going to finish simplifying down here. We might be able to start to notice the patterns. If we see that we have a base of 35 and a log base 35, it's going to just equal x. It's doing the same thing. So this was, again, a log base 2 with a base 2 of exponentiating. So I'm just switching the form around. If the question mark does not work for you, don't use it. This is 35. That's the wrong pen. 35 to the what? We don't know yet. Equals... because it's, yeah, equals. Now my brain has stopped. They're undoing each other. All right, so they cancel out. It equals x. Yeah, because we're logging. There we go. Log base 35 of we don't know equals our power that was log base 35 of x. I'm taking my exponential, 35 to the something, 35 to the log, whatever, right? That's the exponential. So 35 to the something, and I'm putting it in log form. Okay, so my base is 35, becomes the base. The exponent goes to the other side, over here. And what was the argument, which we don't have, we don't know, I'm leaving it as a blank this time. Okay? Yes, we're switching it around, we're changing it around. Okay. A is what we're trying to find. We don't know. So I had it as a question mark on the top row. I did it as a blank here because I feel like the question mark was throwing a lot of us off. I just was trying not to add another variable. We're switching the form around. My base, guys, I need you to lock it back in. I know the hallway was very fun. We're very distracted right now. Okay, so the base of our exponential, so the base here was 35, right? We're switching it in a log form, so it becomes log base 35. On the question, we weren't given an argument. Like, it doesn't have anything over here. We're trying to figure out what that is. So log base 35 of something equals my exponent, e, right? We're switching it around. So then what makes these two match is when this argument is x. Okay? Better? It's going to equal x. Yes? Zoom it in on that. That is all the way out. I can make it go down further, like if you want it to be up higher. I just got to change my zooms to them so I can zoom it back in. Better? Okay. All right. So then they start to go a little bit different because they've got the natural log of e. And the natural log, remember, that's log base e. So log base e, the log and the e cancel out, and they just leave us with whatever the exponent is. Our exponent here is 1. So these guys are inverse operations of each other. And we're left with the natural log of 1. So ln, remember that's log base e. E to the whatever is the inverse operation. They undo each other. So the natural log of e to the whatever is whatever your exponent is. So these guys cancel each other out. Because it's base e. ln has a base of e every single time. We actually have more we can do here. Because ln of 1, that's log base e of 1. Switch it back to exponential form. E to the what? That's a blank. Equals 1. 0. Anything raised to a 0 exponent equals 1. So this whole thing, natural log of the natural log of e equals 0. So let's do the one with the 7 over here. Our natural log of e to the 7th, yes, we switched this back into exponential form. E to the what equals 1. So e to the blank equals 1. Anything raised to a 0 power is 1. Yes, dear. Because by definition, exponentials and logarithms are inverse operations. They undo each other. It's like square roots and squares are inverse operations. Logarithms and exponentials are inverse operations. Yes, ma'am? Up here? Yes, that is a 1 because it has an invisible exponent of 1. We're going to do the same. It's a very similar vibe on the next one. Because the natural log of e to the 7th, the natural log undoes the e, and all we are left with is our power. They're inverse operations. They undo each other. So our natural log of 7 is what we have here. When our base and our logarithmic base are the same, they cancel out. And we can see if we can go any further with this. Let's see if we can get log base e of 7. And we want to know e to the what equals 7. Is that something we know? No. That's our answer. Or that's our answer. Bless you. So it's good to check, but I do not know e to the what equals 7. In fact, very rarely is e going to equal a whole number except for 0. They're not usually going to be this like weird and abstract. More often than not, it's going to be find x, which is what we're going to do next. We're going to solve. Okay. So we're going to start solving these, and we are going to solve as many of these as we can until the end of the day. E is kind of like pi. It's never ending, never repeating, gross. All right. So we've got the natural log of e to the x equals 4. And if it helps, like if you don't want to like remember that natural logs and exponentials are inverse operations, switch it back to exponential form. Take the natural log and put it into exponential form. You can do this as, helps if I use a pen that's properly, there we go. log base e of e to the x equals 4. This is my argument, this is my exponent, and this is my base, right? So my base of e, my power of 4, equals my argument, e to the x. What does x equal? 4. Because e to the 4th equals e to the what? E to the 4th. So it doesn't matter what e is, x has to equal 4. You can also come up here and go, wait, I know that the natural log and the e are inverses of each other, and we get x equals 4. So you can take the shortcut way, or you can go the long way and rewrite it and show how it undoes itself. Okay, same vibe over here. We're going to switch this around back into exponential form. I've got my base, my power, or my exponent, and my argument. So my base of 4, my exponent of 16 equals my argument of 4 to the x. So what does x equal? 16. Okay. Not too bad to start with, right? To start with. I bet it's going to get worse.
I put money on that.
We start out easy and then we crank it up. All right, ready?
Sure.
They're not super bad yet. All right, so we have log base 2 of 8 to the x equals -3. So I'm going to switch this back into exponential form. My base of 2, my exponent of -3 equals my argument of 8 to the x. We're going to have to actually think here. Yes, but we're going to do a few steps in between. What can I do to solve this if we didn't spot it right off the bat? They need to have the same base. How can I write 8 in with a base of 2? 2 to the 3rd. 8 is the same thing as 2 to the 3rd. So we can rewrite this as 2 to the -3 equals 2 to the 3rd to the x. Means we multiply our exponents. See how that one went? So what does x equal? X equals -1. Because the bases don't matter, we're just looking at that exponents. -3 equals 3x, divide both sides by 3, and we get -1 equals x. Okay? The next one's a little weirder. We have a log base x of 1/4 equals 2. So we're going to switch it around. Our base of x, our exponent of 2, equals our argument of 1/4. What do we do next? Find out what x is. You're not wrong. More specific. How do we get x by itself? Square root both sides. So what does x equal? Plus or minus the square root of 1/4. What is the square root of 1/4? 1/2. Square root of 1 over square root of 4. 1 over 2. Can I have a negative logarithmic base? No, we cannot have the base be negative because if we switch it back, that gives us a negative in our base of our exponential. So our answer here has to be that x is 1/2 because you cannot have a negative base. We cannot have the negative base of a logarithm. That's when we get like weird jumpy piecewise-y looking things. Super gross. We're not doing that. Okay, so watch out for that. You cannot have the negative base. You can have a negative exponent. You can have a negative argument. You cannot have a negative base. All right, we are going to keep going. So now we're going the other direction. We're going to be logging things, not switching back from logs to exponentials, but exponentials to logs. I actually just misspoke. We cannot have negative arguments. We can have negative exponents, but not negative arguments, not negative bases. So I misspoke. You'd have to have a coefficient that was negatives in order to make it work. In which case, it's not your argument that's negative. It's the coefficient that made it negative. Okay, so we're going to switch this around into logarithmic form. Because I have an x in the exponent and I cannot solve it because I cannot make 7 and e have the same base. So we're going to need to log it. So we're going to have our log base e of 7 equals 3x plus 2. Well, log base e is actually ln of 7 equals 3x plus 2. I need to get x by itself, so what do we need to do? Subtract 2. Does that mean I write natural log of 5? No. Ln of 7 minus 2. Two separate thoughts. It is ln of 7 minus 2 is not the same thing as ln of 5. Not the same thing. Natural log of 7, period, end of sentence. That would calculate it. So then what are we going to do to get x by itself? Divide by 3. Yes, I couldn't hear you over the chatter. Thanks. So we have our natural log of 7 minus 2 all divided by 3 equals x. And if we were not allowed to use calculators, that would be our answer. That is the exact answer. Air quotes. We can also get our approximate decimal answer by typing the dang thing in the calculator. Because there is a button for natural log and there is a button for the common log. And if you use the yellow calculators, it's got these buttons in this order. Second column, third button down actually lets us put a fraction in. And we can do natural log of 7, close our parentheses, minus 2 over 3. And you can type it in just like this in the yellow calculators. And you guys will get to use the calculators on the test. Like, we are not making you manually calculate logs. What? You would need a table. Like, before calculators could do logs, there were books of calculated logs. Which is part of the reason we have the log properties, is because then they would have to print significantly fewer if we could switch them all into like common log or natural log. But there would be tables and books where you'd have to look it up, each individual value. Super gross. I think you could use slide rules to do logs back in the way back, but I don't know how to do that.
I mean,
That was
you
even
could
before my
also
time.
use brute, like if you put it back into, if you put natural log of 7 back into exponential, you could just brute force it, I guess.
Kind of.
But it'd be off.
It'd be awful. Calculators are our bestest friend. So this is our approximate decimal answer of negative 0.018. We're going to do 3 decimal places. So x approximately equals, that's what the squiggly equal sign means, negative 0.018. So the exact answer leaves it in the gross logarithmic fraction. The approximate solution, we type it into the calculator. All right. It's always a good idea to take a peek back at the original question and make sure that we don't have something against the rules like a negative base. My x is in the exponent. Exponent, it doesn't matter if it's positive or negative, so we don't have to worry too much about a check. The next one's a half notch harder because before I log it, what should we do? Something with the 4. Yes. Divide both sides by 4. So that we get e to the x plus 1 equals 5/4. Now we can log both sides. Log base e, that's the natural log of my argument of 5/4 equals x plus 1. How do we get x by itself? Subtract 1. So our exact answer is the natural log of 5/4 minus 1. And to get our approximate decimal answer, we type it in the calculator. X equals the natural log of 5/4 minus 1. And we get negative 7.78 or negative 7.777. I don't care where we round it. If it matters, I will tell you where to round it. Generally, 2 to 3 decimal places is as detailed as we need to be. Anything beyond that, we're getting into microns, and that's a whole lot of. 7, 8. I'm going to do 2 decimal places on that one. Okay, I want us to do one more because I want to do one of the more complicated-y looking ones, but I want to make sure it matches the stuff that's in the homework. So I'm taking a peek real quick. Cool. So we're going to do the right one. If we have time, we'll do the left one, but we want to do the right one. The left one, you switch it back from log form to exponential, and it's solving a quadratic. You guys can do that. The right one, it looks harder, but it's actually, I think, easier. It's not bad. Because we have log base 5 of x minus 2 equals log base 5 of 3x plus 7. Say it again. We're doing the right one. We're going to do this one. This one. Right one, right one, right one, right one. Just because, honestly, I don't know if we'll have time to do both. And the left one is switch it back to exponential form and solve the quadratic, which y'all could do. You can factor. You should be able to factor. But this one involves some weird thoughts about it. Because what can we do here? I understand where you're headed with that. We can't divide by log base 5 because it's an operation. What we can do is realize, hey, my arguments got to equal themselves. If you're looking for an operation to do there, you can raise both sides to the fifth, like 5 to cancel out the bases. It's called exponentiating. But what we're really saying is, hey, my two arguments have got to equal each other because my log bases are the same. So x minus 2 has to equal 3x plus 7. For log base 5 of those to equal each other, the argument's got to be the same. So how do we solve this? Say it louder. I just couldn't hear you because I'm old. Yeah. Subtract x from both sides. Subtract 7 from both sides. So we've got -9 equals 2x. So what does x equal? -9/2, or -4.5. Is that a valid argument for us to have? If I substitute -9/2 up here in place of x, -9/2 minus 2, my argument is negative. And 5 to the what is -9.5? Nothing. We can't have a negative argument or a negative base. We can have negative powers. Negative powers are totally a thing. But we cannot have a negative base or a negative argument. So this has no solution. Because we can't have negative arguments. Okay? So you've got to check your solutions when you have an x in your argument or when you have an x in your base. You've got to check it. If it's in your exponent, it doesn't really matter because negative exponents are a thing. But if it's in your argument or if it's in your base, you've got to check it. Okay? That is the end of 5.4. Tomorrow we'll go on to 5.5, which is log properties. The answer keys for all the homeworks, I finally updated them. So it's no longer just the number that's written in the problem that's been scanned. Like it's all the work. Because I post the answer key that's like my key, like this.
You know you're supposed to get that, and you're like,
Yes. That's why I'm not stressed about scanning in the teacher version that has the answer is 4. Great. That doesn't really help on everything. But it gives you an idea that yes, I'm headed in the right direction.